There are circumstances in classical mechanics concerning rigid body motion in which non-accelerated and accelerated reference frames, in this video referred simply as observers, lead to conflicting conclusions. For instance, a non-accelerated observer notices a rigid body not acted by any force, moving in a straight path, while an accelerated observer notices the same body moving in a curve. Newton's laws works only for non-accelerated references, giving empirically reliable results. If a body moves in straight path at constant velocity relative to a non-accelerated observer, we can assure it is not under the action of any force. However, this same body motion being noticed by an accelerated observer moves in a curve. This conflicting results causes many interpretation problems regarding the reality of certain forces. Because to explain the bending of the path relative to the accelerated observer, we have to resort to inertial force the body manifests upon itself, contradicting the conditions stated in Newton's laws. Although these inertial forces being manifested by isolated bodies are not real, the matter remains producing confusion and misconceptions. Of course, motion in a curve also happens relative to non-accelerated observers. In this case, a real force is required. Real forces, however, are always produced in pairs of equal and opposite components. The reaction force of the pair must act on another body connected to the first body, causing their conflicting interaction. This is the essence of Newton's third law. Each body resists to acceleration caused by the force pair. This resistance acts on the other body to cause its opposite acceleration. We must not forget that a body moving in a curve is accelerating at the cost of the opposite acceleration of another body interacting with it. This same Newton's third law mechanism occurs in rectilinear acceleration processes. When the forces cease to act, the body moves in straight path in accordance with Newton's first law. Consider a truck moving in a straight road at constant speed. Its cargo box is adapted to contain an internal observer seated on one side, a ball launcher fixed at its rear end, and a receptacle at its front end. In a first example, the ball launcher launches a ball forward with the truck still moving in the straight road, just when the truck enters a curved section of the road. Of course, the truck body and the Earth's surface are interacting and Newton's third law applies. But the ball is assumed not interacting with the truck body. The accelerated observer sees the ball moving out of the turn. Since this requires a force, he concludes that a centrifugal force is acting on the ball spontaneously, because the ball is not interacting with the truck. This spontaneous force is thus an inertial centrifugal force. Since it is well known that a body cannot manifest a spontaneous force upon itself and move, this force does not exist, thus named fictitious. Unlike the accelerated observer, the non-accelerated observer watches the ball moving in a straight path at constant speed, in accordance with Newton's first law. Since it is assumed that it does not interact with the truck body, therefore, the centrifugal force does not exist. Now consider the truck still moving in the straight road, but this time being accelerated. The accelerated observer is seated at the rear end, and the ball launcher and receptacle position transversal to the direction of the truck accelerated motion. The ball is launched, and as soon as it leaves the launcher, it has a velocity v1 forward. From that moment on, the ball is moving free of any force since it does not interact with the truck, assuming no friction, and its forward motion maintains the velocity v1 constant. As the truck is accelerating, the accelerated observer watches the ball moving in a curve backward and concludes that an inertial backward force is acting. This is another example of fictitious force, because the external non-accelerated observer watches the ball moving in a transversal straight path at constant speed, since it is free of interactions in accordance with Newton's first law. The inertial backward force, as the centrifugal force of the previous example, does not exist, therefore called fictitious. The last example, consider a disk rotating at constant angular speed relative to an external non-accelerated observer. An accelerated observer is fixed at the edge of the disk. This observer is accelerated because it rotates with the disk. At the center of the disk, a ball is kept attached to the centerpiece of the disk. A receptacle is fixed to the edge of the disk diametrically opposite to the accelerated observer. It is clearly seen that the disk is rotating anti-clockwise for the non-accelerated observer, but is at rest to the accelerated observer fixed on its surface. At a given moment, the ball is released from the centerpiece. The accelerated observer fixed to the disk sees the ball moving away from the center of the disk and moving in a clockwise curve. For this observer, the ball must be under the action of two inertial forces. A centrifugal force, since it is moving radially away from the center, and a Coriolis force causing the clockwise bending of its path. With respect to the external non-accelerated observer, the ball, when released and assuming no friction, has a velocity v1 to the left. It moves in a straight path at the constant velocity v1 in accordance with Newton's first law. As a result, both the centrifugal and the Coriolis forces are fictitious. In summary, if in the process relative to the accelerated observer Newton's third law cannot be applied, the force causing the motion does not exist, because it would be a spontaneous force that the body applies on itself. Forces are real only when Newton's third law is applied. They are produced in pairs, each component acting on interacting bodies, whose inertial resistances to acceleration act on each other, causing equal and opposite accelerations.